Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. Imagine a short 3-mark question on a GCSE paper. Most students shut the page and panic. Last year, a single circle theorem slip cost whole cohorts 2 or 3 easy marks. Not because the maths was hard, but because the relationship was missed. If you learn one tiny rule today, you turn that panic into instant marks. Sound familiar?
Here's the exact rule. The angle at the center of a circle is twice the angle at the circumference subtending the same arc. No jargon. Center angle equals double the angle on the edge that sees the same arc. Let that sink in. This is a grade 9 move when used cleanly on exam paper.
The concept, step by step. Picture a circle, center O, and 3 points, A, B, and C on the circumference. The arc from A to B is watched by 2 angles, the center angle AOB, and the angle at the circumference ACB, the one sitting on the circle. We want to prove AOB is twice ACB.
Step 1. Join the center O to points A and B with radii OA and OB. Radii are equal, so OA equals OB. That makes triangle OAB an isosceles triangle with 2 equal sides at the center. Because OA equals OB, the base angles at A and B inside triangle OAB are equal.
Step 2. Look at the angles carefully. The central angle AOB sits at the center. The angle at the circumference ACB subtends the same arc AB. If you draw the triangle ACB, the angle at C is exactly the peripheral angle subtending arc AB. Now imagine splitting the central angle by drawing a radius to C as well, making 2 triangles, OAC and OBC. Each of these is also isosceles because OA equals OC and OB equals OC respectively.
Step 3. Use base angles. In triangle OAC, the 2 base angles at A and C are equal. In triangle OBC, the base angles at B and C are equal. When you add the base angle at A from OAC to the base angle at B from OBC, those 2 together equal the angle at C in triangle ABC. At the same time, the central angle AOB equals the sum of the vertex angles at O of triangles OAC and OBC. Each central vertex angle equals twice the corresponding base angle at A or B. Put simply, the central angle collects both base angles once more, giving central equals 2 times circumference. It's tidy if you label each small angle and add them up.
A shorter intuitive picture. The circumference angle only sees the arc from one vantage point on the edge. The central angle sees that same arc from the middle and sweeps across it twice as widely. That geometric doubling is the heart of the proof. Let that sink in.
The exam technique, what examiners want. Let's work a typical higher tier question. Question. In circle center O, points A, B and C lie on the circumference. Angle ACB is 28 degrees. Find angle AOB. Write down the method you would show for marks.
How to present it on paper to get full marks. Line 1, label the diagram. Mark O as center, draw radii OA and OB and tick OA equals OB. Line 2, write the theorem explicitly. Angle at center is twice angle at circumference subtending the same arc. Line 3, substitute numbers. Angle OAB equals 2 times 28 equals 56 degrees. Circle the final answer. That's typically M1 for correct method, identifying relation, M1 for applying the method correctly, A1 for the correct value. Write it down. The examiner wants to see your method. Marks are there for the taking. What if you forget the theorem in the exam? Don't panic. Rescue marks by showing working. Draw OA and OB, state OA equals OB, then explain that triangle OAB has equal sides, so its base angles are equal. Mark the base angles and show the central angle is the sum of two base angles, which match the angle at C. Even if you don't name the theorem, that reasoning can earn you an M1 for method. Write it down, don't just think it.
Common slip to avoid: mixing up which angle subtends which arc. Students sometimes halve when they should double, or apply the rule to angles subtending different arcs. Always mark the arc first, and check that both angles subtend exactly the same arc before using the double rule. This single check saves marks.
The quick win, a 10-second diagram checklist you can use on every circle question. Say it with me in your head as you read a question. 1. Mark the center, O. Tick equal radii. Identify the subtended arc and circle it. Decide center angle equals double the circumference angle, or circumference equals half the center. Write the reason. Angle at center is twice angle at circumference, or show base angle reasoning. Do that every time and you'll catch most mistakes before they cost you marks.
Quick shorthand to remember in the exam: center equals double and edge equals half. If a question gives an edge angle and asks for the center, double it. If it gives the center and asks for the edge, half it. Write the operation beside the angle so the examiner can see the arithmetic. Don't skip the check. Substitute or draw a small tick to show which arc is used.
The outro. One sentence recap and call to action. The angle at the center is twice the angle at the circumference, subtending the same arc. Use the 10-second checklist and write your method to grab easy marks. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.
Bonus practice in next steps: 2 quick practice questions and a 15-minute revision plan. Question 1, starter. In a circle centre O, angle ABC is 35 degrees, with ABC on the circumference. Find angle AOC. Question 2, stretch. In circle centre O, points A, B, C and D lie on the circumference. Angle ABC is 22 degrees, and angle ADC is 40 degrees. Show whether AB and CD are equal in angle terms, and find angle AOD. Work question 1 in 5 minutes using the checklist. Spend the remaining 10 minutes on question 2, drawing clear radii, labelling arcs and writing reasons for each step. For parents and teachers, run this as a 15-minute focused slot. 5 minutes, demonstrate the proof on a board. Emphasize the center equals double phrase. 5 minutes, students practice question 1 and swap answers with a partner to check the diagram labelling. Final 5 minutes, tackle question 2 as a challenge and discuss the marking points. Identify where method marks are awarded and where students commonly lose marks. Same method, different numbers. Repetition builds fluency.
If you want worked solutions for the practice questions and a pack of 5 more progressive problems with mark schemes, go to jcacademyonline.co.uk. The link's in the show notes. That's a compact set designed to be used straight away in single revision sessions. Trust the process and nail that exam. Stay curious.